Welcome to the deep dive. Today, we're jumping right into the Great Eurasian Weather Divergence. We're talking about the forecast for December 24th through the 31st, 2025.
And it is a really stark forecast. It's essentially a structural split across Eurasia.
A violent one. You're looking at two completely different and very dangerous weather regimes happening at the exact same time.
It's a true dual threat. On one side, you've got this high-energy maritime storm regime in the west, think flooding.
And on the other,
A severe continental winter regime in the east, a deep, paralyzing freeze.
okay, let's unpack this because the driver here is, well, it's not what you'd think. It didn't start at ground level.
No, not at all. The real catalyst was an early-season major sudden stratospheric warming, an SSW, that happened way back in late November.
So something warmed up high in the atmosphere.
Exactly. The stratosphere got very warm very suddenly, and it caused the polar vortex to basically collapse. The winds up there didn't just slow down, they actually reversed.
Which means the gate that usually keeps all that Arctic cold locked up just swung open.
That's the perfect way to put it. The tap is open, and all that frigid air is now spilling south. It's a phenomenon some are calling thermal whiplash.
I like that. It captures that violent swing between extremes. So let's talk about the first extreme then, the storms in the west.
Right, the Maritime Storm Regime. This is being supercharged by unusually high sea surface temperatures in the Atlantic. It's just pouring fuel on the fire.
Fuel for what meteorologists call intense cyclogenesis.
And the main event here looks to be a storm they've named Chandra. It's forecast for December 25th to the 27th.
And the models are showing it could become a, what was the term? A monster 930 bar bomb cyclone.
Yeah, 930 millibars.
Wow. Just so you know, that is not a typical winter storm. That's pressure you'd normally see in a Category 3 hurricane.
It is, and it's on a trajectory for the UK, Ireland, and northern France with wind gusts up to 160 kilometers per hour. The main threat isn't even the wind, it's the rain. Potentially catastrophic flooding.
Okay, so while that's happening, let's go 2,000 kilometers east. The exact opposite scenario is playing out.
The other side of the coin, that same polar vortex collapse has allowed a stable, persistent frozen dome of Arctic air to settle in.
And we're not just talking a little chilly. Moscow might be, 5 to 10 degrees Celsius below normal? But the real cold is further east.
Right. Look at a city like Novosibirsk. The forecast there is for minus 31 degrees Celsius.
And at that temperature, you get ice fog, don't you?
You do. It's microscopic ice crystals suspended in the air. Visibility drops to almost zero. It grounds aircraft, paralyzes highways. It brings everything to a standstill.
Okay, so this is where it gets really interesting for me. What happens where these two systems meet? The hurricane-fueled moisture and the cryogenic dome.
That's the flashpoint, the collision zone. And it's the most hazardous part of this entire setup, running across Germany, Poland, and Belarus.
Why so dangerous?
Because you have warm, moist air from the Atlantic flowing over this incredibly dense, cold air at the surface. This creates a phenomenon called thickened icing.
So rain that freezes instantly on contact.
Instantly. The forecast is for a 1 to 3 centimeter crust of solid ice on everything.
And that weight is just beyond what the infrastructure can handle. Power lines, rail systems.
They're not designed for that. You're looking at widespread systemic power grid failure, total logistical paralysis from black ice. It's a nightmare scenario.
And if we zoom out, the sources we're looking at are pretty clear. This isn't some freak event. This is a preview of the new baseline.
I mean, that seems to be the consensus. The underlying driver is Arctic amplification. The Arctic is warming so much faster than the rest of the planet.
Which weakens the jet stream, right? It makes it wobble and meander, so these weather patterns get locked in place for longer.
Exactly. And you have to consider the timing. This is happening during peak holiday travel, with security already on high alert for things like drone disruptions.
It's a massive force multiplier for emergency services. They're stretched thin already.
How do you fight catastrophic floods and a deep freeze at the same time?
It really poses the central question for the 21st century. We have to survive these transitions, these rapid, violent swings. It makes you wonder if the 1-in-100-year event is now just December. What fundamental changes do we need to make? Something to think about.